Hello, welcome to the video notes for lesson 7.5, and this is about linear functions, and this is the first part, or the first day, for this video. This begins on page 24 in your notes packet, and our target for this is I can determine if a function is linear by determining if it has a rate of change. Now, this right here, this rate of change, is a really big idea. So it's important for you to pay attention in this video, and when you're done, you need to understand what this is all about. There's different ways to talk about what rate of change is. Okay, so first examples that we have, which graph is linear? When you're looking at a graph, deciding which one is linear is easy. You're looking for a straight line. So the first one is obviously not, because it's a curved line. Same with graph 2, we have a little bit of a curve to it, so there's no way that's linear. The next one, some people might say that they see a straight line in here, but if you follow it, you get to this point here and then it goes in a different direction. That is not a straight line. So the only one that is a straight line that is linear is the last one. Now, when we're looking at an equation, if you remember from earlier, we were talking about linear is when it has just a single variable, then it's linear. So we have just a single variable here, x. So even though it's being multiplied by 2/3 and we're adding a number, this is linear. Now the next one, if you notice, we have x, but we also have x squared. X to the second power is not a linear function. It will not create a straight line. In fact, I'd be curious to know if any of you know what this does create. So, if you can tell me in math what kind of graph x squared plus 3x minus 28 creates, it has a special name, I'll give you a point on your scoreboard. Let's add one more example here. We're going to add example 3, and we've got h of x equals the absolute value of negative 5x. And this one is also not linear. Remember, an absolute value graph is V-shaped. So the only one that creates a straight line is the first one. Alright? Now, I know that when you look at a graph, that's easy to decide if it's linear. Some of you are probably getting really good at identifying it when you look at an equation. But when we look at a table, it might be a little harder to spot. So at the bottom, which table is linear? When you look at it, it's hard to say which one is going to create a graph that is a line. Some of you may be able to map it out in your mind, but it's better to know, and that's where our idea of rate of change is going to come in. Alright, so let's go ahead and look over on the next page, and you'll see the tables and the graphs that go with them. So this table here goes with this graph. Now, if we look at the input values first, the input values just increase by 1 each time. That seems like a steady rate of change, which is what you're looking for with a line, a constant rate of change. But then when we look at the change in the output values, first it goes down, and then it goes back up. A line does not do that. Well, I almost gave it away. Something else, whatever this is called, goes down and comes back up. So this one, this table is not linear. No, or not. The next one obviously is, because when you see the graph, you see the straight line. But let's take a closer look at the input and output values. So, the input values are increasing at a constant rate, and the output values are decreasing at a constant rate. And together, this is going to create a constant rate of change. And by the way, that constant rate of change is -4, or -4 over 1. So obviously, the middle one is linear, and then the bottom one is not. Again, let's look at the values. So the input values are changing at a constant rate. They're increasing by 1 every time. But when we look at the output values, some of you might be saying, well, there's a rate there. It's doubling each time. That is not the same as adding or subtracting. This is actually what's known as an exponential curve. So it is not a straight line because it's doubling. It's not increasing or decreasing at a constant rate. Okay? So, this is what's called an exponential, which is something you'll be learning about later on this year. So this is also not linear. Okay? Alright, so over on the next page we have a little more information about what a linear function is. So let's go ahead and take a look at that. Now we're up to page 26. A linear function is a function that has a constant rate of change. So then its graph is a straight line. I want you to underline this, highlight it, put a star around it, memorize it. We're going to be saying this a lot because this is the big idea. A constant rate of change. So, a slope of a line is the ratio that compares a vertical change to the corresponding horizontal change. What the heck does that mean? Well, think about vertical. Vertical is up and down. So the y values. And then the corresponding horizontal change. So that's the x values. Remember when we were looking at that table and we were talking about how it increased, the x values were increasing by 1 and then the y values were decreasing by 4? That is a slope or a constant rate of change. You can also describe slope as rate of change. A rate of change is a comparison between two quantities that are changing. So here is that big idea. Slope, or the rate of change, is equal to vertical change over horizontal change, which equals, now you see this little triangle symbol. That's like a Greek symbol, and what that means is the word, it stands for a letter, delta, Greek letter delta. What it means is the change in y over the change in x. So remember, that other one was decreasing by 4 every time for the y value, but increasing by 1 every time. So -4 over +1, or just -4. That is the slope of the line. So we've got this example here where you see the x values are increasing by 3 each time. And you'll notice that you can see in the graph that it is a straight line. So it's increasing by 3. And then the y values are increasing by 2. So if we want to find its slope or its rate of change, we can take this change of y, delta y, over the change in x, and put that equal to 2 over 3, 2/3. So every 2 units it goes up, it goes 3 over. 2 up, 3 over, 2 up, 3 over. And when you get good at this, you can end up graphing all your points without even looking at the point values and just plotting them. Alright? So let's take a look at another example. So you can find the rate of change from a table, or excuse me, does the table represent a linear function? So we've got here an increase by 1 each time. Oops. And then we have an increase by 3 each time. So this is our y, this is our x. The change in y, or delta y, over the change in x is 3 over 1, plus 3 plus 3 plus 3, over plus 1 plus 1 plus 1, or 3 over 1. So there's the slope. And again, we can plot the points by saying, okay, well, every time we go over one space, we go up 3. Or you can say, when you go up 3, you go over 1. Up 3 over 1. Either way works. Alright, let's take a look at another example, and then I'll let you try this on your own. This video is getting long. Does the relation defined by each table represent a linear function? Explain. So watch. So, this is increasing by 1 each time. The input is the x. The output is the y. So since this is increasing by 1, so far so good. Now the next, plus 2, plus 3, plus 4. Wait a second. Whoops, I made a little mistake there. From 7 to 8 is actually increasing by 1, and then plus 2. Alright, so is this a steady rate of change? And the answer is no. There is a constant change for x, or the input. Well, how about this? We'll just say no. There is no constant rate of change. Alright? Now, I want you to try B and then the one on the bottom, all on your own. Again, try to find, to see if there's a constant rate of change for both the x and the y, the input and the output. And then make sure you explain your reasoning. And remember, if you want to earn a point on your scoreboard, name the graph, that's the funny looking graph that's U-shaped. And also, for a couple more points, without telling anybody, if you can share all the different names for a constant rate of change. So if somebody says you learned about a constant rate of change, slope, change in y over change in x, vertical change over horizontal change, that's 4 different things. Those are all the same thing. So if you mention those things, that you learned about those in the video from different people, if I hear it from, without telling anybody, I'll give you more points on your scoreboard. Good luck, and we'll see you in math.